Okay, so now let's talk about the planet Mercury. So this is going to be the first planet you come to after you working your way out from the sun. Okay, now let's talk about the size of Mercury. So if we go back to this picture here, you can see the size of Mercury, and you notice it is bigger than the moon, but not by much. So it's roughly the same size as the moon, and that's going to give you a clue as to why did Mercury end up the way it did. It's going to have to do with its size. The picture that is to the right of that shows you what the surface of Mercury looks like. Notice it looks very similar to the surface of the moon. It's heavily pockmarked by craters. The picture that is to the far right shows you what does the inside of Mercury look like, and you'll notice it has a very large iron core. The iron core, the solid iron core inside of Mercury is even larger than the solid iron core that's inside the Earth. And we'll talk about that in just a moment. All right, so the next thing would be, what about the rotation rate and what about the orbital rate of Mercury? And I wouldn't want you to have to know the numbers for how long does it take Mercury to rotate and how long does it take it to orbit. But look, compare those two numbers to each other, and you notice that they're fairly the same. What does that tell you about Mercury? Mercury, given enough time, the rotation rate of Mercury will eventually match its orbital rate, for the same reason that the rotational rate and the orbital rate of the moon are locked due to the gravity of the Earth acting on the moon. In this case, it's due to the gravity of the sun acting on Mercury. So just kind of interesting stuff. Okay, now let's talk about the atmosphere. You should be able to tell me what the atmosphere is going to be like on Mercury. It's going to be very thin because Mercury is very small. It's not going to have much gravity. So that's going to tell you the pressure is going to be very low. Okay, look at the temperatures on Mercury. On the side that gets sunlight, it's very, very hot. On the side of Mercury that doesn't get sunlight, it's very, very cold. You might think that because Mercury is so close to the sun, it would be hot all the time, but it's not. So it's hot on the part that gets the sun, and it's hotter than the moon because it's closer to the sun than what the moon is. But on the night side, it's very, very cold. Okay, so another thing about Mercury is that it has a comet-like tail. Gases that are being blown off the surface of Mercury. So that should pose a question to you. How could Mercury have an atmosphere at all? Because it's so small, it's going to lose that atmosphere into outer space because it doesn't have much gravity. So how could Mercury have any kind of atmosphere whatsoever? It comes from the sun. So hydrogen and helium are blown off the sun. It accumulates on Mercury, but just as quickly as it accumulates, it leaves, and the solar wind of the sun makes Mercury have a tail just like a comet. And those are gases that are being blown off into outer space. Another interesting thing about Mercury is look at its orbit. So that picture there, which it kind of looks like a spiral graph in which you've got the sun is located here, and then here is, now this is greatly exaggerated, but let's say that that's the orbit of Mercury. But notice that it doesn't return to its original starting point over here. So on its next orbit, it does something like this. And then on its next orbit, it does something like that. So the orbit of the Mercury is precessing, the same way that the spin rate of the Earth precesses. So if you take a top, okay, you wrap a string around a top, you pull the string, you put it on the table, so it's spinning, okay, but you'll notice that as it spins, so it's spinning like this, it also does this, and we call that precession. So it's the change in the spin rate, or the direction of a spin rate, due to the gravity of the Earth pulling on the top. Well, the gravity of the Sun pulling on the orbit of Mercury makes it precess. So this was predicted by general relativity and was verified by that. All right, okay, so now let's talk about plate tectonics. So what do you think about the plate tectonics on Mercury? Yeah, not really going to have much because it's so small, it cooled off rapidly. The inside cooled off rapidly so that its plate tectonics was lost. Okay, it does have a large iron core. So why would Mercury have a large iron core? Okay, do you remember when we talked about the formation of the solar system and we talked about the ice line, and we said that inside the ice line, the heat from the sun would not keep ice in a solid form. So that ice was driven to the outer part of the solar system where it was colder. Well, now let's think about rock and metal. Which of those two substances would be able to survive the highest temperatures? It's going to be the metal, okay? So that metals such as iron could exist the closest to the sun, and then a little bit further out is where the rocks would be. So Mercury has a higher content of iron because that iron could survive those higher temperatures. Okay, some other things about Mercury. It does have a little bit of a magnetic field. It does have some cracks on its surface that kind of looks like plate tectonics, but really those cracks are a result of shrinkage. So that Mercury was kind of poofed out when it first formed due to heat, but as it cooled off, it shrank a little bit, and so it made wrinkles, and so those are what those cracks are that you see on the surface of Mercury. Mercury could have water, and so the water is going to be frozen in craters on the surface of the planet. As long as those craters never get any sunlight, it's possible that there could be water in the bottom of those craters frozen. So even though the temperature when the sun is out gets incredibly hot, if you're inside of one of those craters, there actually could be water ice on the surface of Mercury. That bottom picture there shows you the topography of Mercury. And so the blue areas represent low areas, and then the brown areas represent the mountainous regions of Mercury. Okay, so let's take a break. When we come back, we're going to talk about the planet Venus.